In case you didn't notice so far, those numbers, by the way, are just representing the left numbers always representing the shrink value, the right numbers representing the grow value. I think I didn't mention this so far, which is pretty stupid actually. But I guess most of you just noticed, and if you didn't, now now you have it. Okay, so um, maybe you remember when we started talking about flex basis, we I actually told you that there are two useful ways how to define it. Now, the first way we mentioned was to think about it as the ideal size along the main axis, or the size that the elements want to have along the main axis. Now, for the second definition, this is actually touching what we are working on right now, which is the shrink and the grow properties. Now, one question we didn't ask yet was, maybe you asked the question for yourself, but I didn't answer it definitely yet, is what's actually about this name? Why is this called basis? Now, normally things are called size, width, or height, stuff like that. We know what that means. Why is this called basis? It has to be a basis for something. And that's exactly what it is. Now, flex basis is a basis for the shrink and the grow, basically. And in other words, when you have enough space in your container, flex basis tells you how to set your size, but when you have to distribute the space, what you do with shrink and grow, flex basis is telling you with what value to start when you distribute your space. So Flexbox, whether it has a specific pixel value or it has a auto value, which is looking at its content, it calculates some value, some basis value, and this value is kind of the start value to decide how should I grow and how should I shrink. And we can actually see this pretty nicely in this case here. Now, we said we have three elements that have different grow values. The green element has a grow value of 3, this has one of 2, and the first one has a grow value of 1. Now, what you can notice, however, is that this does not mean that the green element is 3 times as big as the red element. It is just a little bit bigger, and the yellow element is also a little bit bigger than the red element, but smaller than the green element. Watch what happens when I take those elements. They have a flex basis of 200 pixels so far, which means that when you add all of those 3 flex bases, you would still have some space left. Now, when I change that and I would set them to, let's say, 400 pixels, each one of those elements, now you can see the elements are exactly the same size. So it seems like the grow property actually doesn't affect them. And that is what is happening. And the reason that is happening is that they look at their flex basis, which is 400 pixels, and they say, okay, we can probably not even use those 400 pixels. Now we can even magnify this effect when we go to 600, because then we definitely know that there is not enough space for all those elements to have 600 pixels. And it uses this as a basis to ask, can I grow or can't I grow, right? Am I allowed to grow or not? And they are not allowed to grow because they didn't even reach their flex basis, so there's no point in actually growing. Now, on the other side, if we kind of go into the exact opposite direction, we set a very small flex basis. Now you can see they have significantly different sizes. And that is why, that is because, let's just for a second remove the grow on all of them. That is because they start at their flex basis, which is 100 pixels. This would be this size that they have right now. And now they say, okay, listen, we have this much space left. So if we are allowed to grow, we have to distribute this space that our containing element left us, and we will distribute this space along our particular grow properties. So when the green element gets a grow of 3, it gets kind of, you could think about it as it gets 3 portions of this space that is left here. The yellow element gets 2 portions, and the red element gets 1 portion. And you can even magnify this effect when we zoom out a little bit and we increase the containing element. Now you can see the bigger we get, the bigger the difference between them is. If we would go kind of infinitely large for our containing element, then the ratio of the flag spaces would be smaller and smaller because those 100 pixels would mean less and less, and the space that was actually free would be bigger and bigger, and that would mean that they would then actually approach this ratio of the green element being 3 times as big as the red element and the yellow element being twice as big as the red element. So let's just once again remove the grow, just to make this point clear. Some familiar UI Toolkit bug. Okay, and now we can see we have a lot of space left. And again, this space is going to be distributed according to the particular grow properties. So when we give the green element a grow of, let's say, 5, it will use up 5 of those 5 portions of this free space. Of course, not now, because we didn't, it doesn't have to compete with the others because they don't have a grow property. So if just one element has a grow property, obviously it is covering the whole space. It doesn't matter how much I give it, because the other ones are not allowed to grow at all. It's the only one that can grow. So the particular value doesn't actually matter. I hope that that's clear. But let's again change it back to 5. Let's go and give the yellow element a grow of 3 this time, and the red one of 1. And now you can see we have those ratios of the green element being significantly larger than the yellow element, and the yellow element being significantly larger than the red element.